So hello, so we'll be discussing some problems on truss. So truss is before solving the actual problem, we'll discuss some basic concepts on trusses, right? So a truss consists of planar truss. We'll be discussing only about planar trusses. Uh, in a planar truss, each member is a two-force member, meaning that this member or any member in a truss can take up load only at the endpoints, right? So a member cannot take load something like this, right? Also, it cannot take any momentum, so this is not possible. All right, so in a truss, each member, internal forces of each member is only tensile or compressive, right? So this is not the external force, mind you, this would be the internal forces. So here this 100 kilonewton is the external force that is acting upon this joint B, right? So due to this external forces and also the supports given to this truss, so there will be internal forces generated to it, right? So I'll not go into the theory in depth, but each uh, member in a truss will develop some internal forces, right? So that internal forces will be only tensile or compressive. So while writing the free body diagram, to solve any of the trusses, we have to write the free body diagram and solve each and every joint or each and every hinges. We'll go through that while writing the free body diagram. So we have to the usual sign convention is we consider the forces to be the unknown forces. Let's say we are in this question, we are trying to find the force of member A, AC. So we don't know whether it has tensile forces or compressive forces. So by convention, we'll just assume that the internal forces in AC will be tensile, right? So if the answer that we get is positive, it means that the direction that we have assumed is right. So the forces is tensile. If the answer that we get after solving is negative, it means that the forces that is actually acting upon AC is not tensile but instead compressive, right? So with this basic knowledge, let's start solving question. Okay, right. So here, as asked us to find the force in member AC, right? So to do this, we can the usual convention is, if there is a fixed support, so there will be two forces, right, along the x direction. Let us assume this would be the coordinate system del x and this is the vertical would be y. So there will be two forces or the reactive forces acting upon this um, hinges. So the free body diagram would look something like this, right? So if this is point D, this is C, let's say this is A and this is B, right? So at B we have 100 kilonewton force, at A we have a support. If it is a fixed force, there will be two forces acting along the x direction, the other one acting along y direction. Mind you that these directions does not mean anything. Again, as I mentioned, if the answer that we get is positive, that means this assumed direction is correct. If we get negative, the forces is acting in the opposite direction. So no need to worry much about this direction. So also at point D we have another support. We will have dx and also dy, right? So this is the free body diagram. This, and we have to find force in the member FAC. This is the question, right? To do this, we can either take the moments and solve for each of this, or we can start from this point and move accordingly. So I'll only consider point joint B and I'll write the FPDD of joint B. Okay, so at joint B, what do I have? I have an external force acting, that is 100 kilonewton, and also I'll be assuming each force is tensile, right? So I have FAB and also I have FBC, right? So the angle between these two is, they've also given that this height is also 1. Okay, so we have, if the height in this right angle triangle, if the height and also the base is 1, this angle would be 45, because tan theta is equal to opposite divided by adjacent. 1 divided by 1, that will be only holds good for 45 degree. So we have 45 degree. So this is vertical unless other mentioned. So every vertical line we will be considering it as a 90 degree or a normal line. Okay, so I have three forces acting at a point. I can apply Lamins theorem, right? So according to Lamins theorem, what does it say? I will be writing first force FBC divided by sine of the angle between the other two forces. If I am considering FBC, the other two forces are FAB and 100 kilonewton. The angle between those two is 90 degree, right? That will be equal to the next forces FAB divided by sine of the angle between the other two. The other two angle is, we have, from here to here it is 180 degree, 180 degree plus 45 degree. So that is sine of 225 degree. So that would be equal to F, that will be equal to the other forces 100 kilonewton, that is 100 divided by the angle between the other two forces is sine 45. Okay, so now the unknown forces are these two. I'll just equate this individually and find out the answer. Upon simplification, we will be having FAB is equal to minus 100 root 2 into 1 by root 2. Root 2 will be cancelled. FAB will be equal to minus 100 kilonewton. Also FBC will be equal to, again they will be having 100 root 2, here sin 90 is 1, FBC is equal to 100 root 2 kilo Newton. Okay, so I'll consider now joint C, FBD of joint C. So at joint C we have the following, right? So this is C. I have one force something like this. This is FBC, let's say. The other force is horizontal. So this would be FDC, and also another force going to joint A, that is FAC. This is what we have to find. So so in this triangle, even this angle is 45 and this angle is also 45. If this angle is 45, then this angle is also 45, right? Basic geometry. So we'll have this angle as 45 degree, right? So either I can apply Lamins theorem or I can go for the conditions for static equilibrium, that is Fx is equal to 0 and Fy is equal to 0, right? So there is no point in applying sigma m is equal to 0, as all the forces will be passing through this point, right? So I can apply these two. So but the simple technique is applying Lamins theorem, right? So we have this angle is 45 and this angle is 45. So this whole angle is 225 degree. So these are perpendicular line, right? So we have FDC divided by sine 90 degree is equal to FAC divided by sine 225 degree is equal to FBC divided by sine 45 degree, right? So if I'm considering FBC, the angle between the other two forces is 45 degree. Similarly for all of this, so the unknown force that what we need to find is FAC. I'll equate to that. FAC divided by minus sine 45 is equal to FBC divided by sine 45. Okay, so sine 45 and sine 45 is cancelled. FAC is equal to minus FBC, that is equal to minus 100 root 2 kilonewton. So since we have minus, it means that FAC is equal to 100 root 2 kilonewton compression. So first option is the right one. Okay, so the second question is determine the force in the member AC of the truss given. Use the negative sign to indicate the compressive force. So what we have to find this force. Okay, to do that, again we can take the reactive forces and so go on solving, but that will be a very lengthy procedure. Instead, we'll have to find a joint where we have only 3 or less forces, right? So we have joint B which has only 2 members or 2 forces, so this can easily be solved, right? So we'll have one force somewhere here and another force somewhere here, B, F, AB and F, BD. So by applying simple sigma x is fx is equal to 0 and sigma fy is equal to 0, we can say that FAB is equal to FBD is equal to 0. Alright. So, and then I'll go for joint A. In joint A, I have 1 force, 2, 3 and 4. I know this force, that is FAB. I already found out this one, and I'll have to, I don't know about this force and I don't know about the unknown force. Alright, let's find out, let's try to draw the free body diagram at joint A. So I have external force of 20 kilonewton and FAB, and I have FAC and FAD. So the angle between this that we have to find. Okay, so how to find out? Just by using basic geometry. So we have this horizontal distance given as 2.5 and the vertical distance given as 2. If we consider this right angle triangle ABD, we can say, let's say this is theta, we can say that tan theta is equal to opposite, that is 2, divided by adjacent, that is 2.5. Tan inverse, theta is equal to tan inverse of 2 divided by 2.5, that is equal to 38.65 degree. Okay, so theta is equal to 38.65 degree. Okay, so now in this, let's apply the condition for static equilibrium, that is sigma fx is equal to 0. So again, all the right moving forces will be positive and the left moving forces would be negative. Similarly, in the y direction, vertically upward would be, I'll consider this as positive, and vertically downwards I will be considering this as negative. It's not necessary that this would be we have to use this sign convention. We can also use the other one, but we'll have to stick to it throughout, right? So we have 20 plus 20 plus FAB also plus FAD cos of 38.65 is equal to 0. So FAB is equal to 0, and we have FAD is equal to minus 20 divided by cos 38.65. So this would be equal to FAD is equal to minus 25.61 kilonewton. Okay, so sigma Fy is equal to 0, the other condition for the static equilibrium. So according to this, we'll have to equate all the vertical moving forces. So minus FAC minus FAD sine of 38.65 is equal to 0. There are only two vertical forces. I can take negative common and I can cancel out the minus. So I'll have FAC is equal to minus FAD sine of 38.65, right? So this would be equal to 15.995 kilonewton. So the negative sign and the negative sign will be cancelled, we'll have positive. This would be tensile, right? So the nearest option is we have plus 16.16 kilonewton. So question number 3. So find the force in the member AC. Again we have to find this one. Okay, so here if we directly go on solving with the member of joint using the individual joints, we'll not get the answer. Instead we'll also have to use this information of reactive forces. I'll consider this whole body, whole truss as a single member, and I'll try to solve for this reactive forces, right? So if I consider the FBD of the whole body, so mind you that I am not considering each and every member, I am considering the whole body. The whole body will also be in static equilibrium, right? So I can apply all the formulas of the static equilibrium. So if this is the body, I have an external force of 1000. So given that they have 1000 kilonewton, external force of 1000 kilonewton, the angle is 60 degree, right? So the fixed joint, I'll have a vertical force, I'll name it as AY, and an horizontal force AX. So here this is a roller support, right? So this gives only, this restricts this body to move in vertical direction. So the body is free to move in this direction but not in this. So this restricts only vertical direction, so there will be only reactive forces in the vertical direction only, wherever we have a roller joint. So only BY. So there will be no horizontal component. Okay, so after this I can apply the equations of static equilibrium, that is sigma m is at any point in this member will be equal to 0, sigma fx equal to 0, and sigma fy is equal to 0. I have to apply only usually we'll have to apply the moment at this, also this point, right? So first I'll apply sigma ma is equal to 0 at point A. So we'll have, given that I'll have to also find the moment is nothing but force into perpendicular distance, right? So I know the force but I don't know this perpendicular distance. I know the distance from here to here. I'll have to add this distance. To find out that distance, I'll consider this construction, let's say triangle EDO. In this right angle triangle, I know this angle is 60 degree. I'll consider sine 60 degree is nothing but, I'll say EO divided by this ED is equal to 1. So EO will be equal to sine 60, that is root 3 by 2. So the whole distance from 1000 kilonewton to the horizontal line will be 1 plus this distance is root 3 by 2, right? So I have 1000. So this 1000 kilonewton tends to rotate the body in clockwise direction with respect to this point, right? So I have plus 1000 here. Also clockwise rotation is always considered as positive. It doesn't matter, I can also take it as the negative sign, but we'll have to be consistent throughout the problem, right? So I have 1000 into the perpendicular distance is 1 plus root 3 by 2. Also I have, since these two forces are passing through the point A, the perpendicular distance will be 0. There is no use of considering these forces. So the only other force left is FB. This tends to rotate the body in anti-clockwise direction, so I'll have negative sign By into perpendicular distance is 1 will be equal to 0. Alright, so upon simplifying, I'll have By is equal to 1866.025 kilonewton. Okay, so next I'll consider sigma MB is equal to 0. So what I'll have is this 1000 kilonewton, the external force tends to rotate the body in clockwise direction, so again I'll have 1000 into 1 plus root 3 by 2 and plus, because AY is also tending to rotate this whole body in clockwise direction, I'll have AY into 1 is equal to 0. This implies that AY is equal to minus 1866.025 kilonewton. So here the negative sign suggests that the AY direction is vertically downwards, right? So we should not rub, since we get a negative sign, we should not rub this sign and just assume they are reverse. We'll stick to this when we will use negative sign wherever AY pops up in further, right? So next I can also apply sigma Fx is equal to 0. The only horizontal force here is Ax and 1000 kilonewton. So I'll have Ax is equal to minus 1000 kilonewton. So now I'll consider joint B, right? So in joint B I have 1, 2 and 3 forces, right? So I can write the free body diagram. I'm sorry, this is the joint B. I have 1, 2 and 3 forces, so I can write the free body diagram as 1, 2 as well as 3 forces. So this force is FAB and this force is FBC and this is BY, right? So I can apply sigma Fx equal to 0 and sigma Fy is equal to 0. So I can write, by applying the sigma FB, I can write sigma FBC plus BY is equal to 0. FBC is equal to minus BY is nothing but 1866 minus 1866.025 kilonewton. Okay, and sigma Fy will have, there is only one horizontal forces, it means that sigma FAB is equal to 0. So now I'll move on to joint A. Okay, so in this joint I have 1, 2, 3, 4, 5 forces. Okay, I'll write the free body diagram. 1, I have 2, 3, 4 as well as 5. So this is AX, AY, FAB and FAC. So this angle is 45 degree because the horizontal as well as the vertical distance here is 1 and 1. This is a square, this is a diagonal angle will be 45 degree, right? Basic geometry. So this is FAB. Okay, so now I can apply sigma fx equal to 0. Sigma fx equal to 0, I'll have ax plus FAC cos 45 degree plus FAB is equal to 0. So FAB is already 0, we know that from this. Also FAC by root 2 is equal to minus AX, right? FAC is equal to AX is nothing but minus 1000, right? AX is equal to minus 1000, so I can write minus into minus plus 1000 root 2 kilonewton. So since we have positive, this is tensile. The correct option is so if you simplify this, I will have 1414 kilonewton, right? So the correct option is option D. So here again I'll consider the whole body as one single unit. So I'll write a free body diagram for this. I have one force here of 10, another 10 kilonewton here, fixed support here. So I'll have horizontal as well as vertical reactive forces. Here I'll have only vertical reactive forces because I have a roller joint here. So AX, AY, and this would be EY. So the distance here is 3 and 3. So this distance is 1.5 and this distance is also 1.5, right? So I can take moment about A is equal to 0. So since this body is in static equilibrium, I can apply this moment about point A, right? So moment about point A is firstly 10 kilonewton. 10 kilonewton tends to rotate the body in clockwise direction, right? So I'll have positive sign for it, 10 into 1.5 plus again have another force 10. This also tends to rotate the body in clockwise direction, 10 into this distance is again 3 plus 1.5, that is 4.5. okay, so this angle is 60, even this will be also equal to 60 degree and 60 degree, and this distance will be also equal to 3. Why? Because even this is an equilateral triangle, then this shares one side with this equilateral triangle, so all the sides would be equal to 3, right? So 10 into 4.5, and this EY tends to rotate the body in anti-clockwise direction, so we have minus EY multiplied by 6 plus 6 is 3 plus 3 is 6 is equal to 0. So it implies that 6 EY is equal to 15 plus 45, that is 60. This implies that EY is equal to 10 kilonewton. So next we have sigma ME is equal to 0, right? Sigma ME, this is E, right? So we have AY multiplied by 6, distance to rotate in clockwise, and these two 10 Newton tends to rotate in anti-clockwise direction, minus 10 into again 4.5 minus 10 into 1.5 is equal to 0, and this also implies that 6 AY is equal to 60 and AY is equal to 10 kilonewton. Okay, so now I'll consider joint A. So the free body diagram for joint A is, so I have one force here to joint B and to joint A and two reactive forces, right? I have something like this: AX, AY, FAB and FAD. So this angle is 60 degree, right? Sigma AY will be equal to 0. Why? Because if I apply sigma Fx equal to 0 for the whole body, there is no horizontal forces, so Ax will be equal to 0, right? So I can just neglect this thing. So since I have three forces, I can apply Lamins theorem, right? So according to Lamins theorem, so this angle is 90 degree and this angle is 180 plus 30 degree. So this whole angle will be equal to 180 plus 30 is 210 degree. So I can write, so to write Lamins theorem, I have to make some changes for this free body diagram, right? So the forces have to origin from the same point, so I have to write, so FAB, so this would be FAD and this will be AY. So this is 30 degree, so this is 60 degree and this would be 270 degree. Okay, so I have, according to Lami's theorem, I'll have AY divided by the angle between the other two forces, that is sine 60 degree, is equal to FAB divided by sine of 210 degree is equal to FAD divided by sine 30 degree. Okay, so I have to find FAB and FBC. FAB is given by AY is 10 divided by 10 into 2 divided by root 3 into sine of minus sine 30, right? So sine 30 is 1 by 2 and this 2 will be cancelled, so I'll have minus 10 by root 3 kilonewton. Also I have FAD will be FAD divided by sine 30 is equal to AY is 10 divided by sine 60 is root 3 by 2. Okay, so FAD is equal to 10 into 2 divided by root 3 into 1 by 2. 2 will be cancelled, this will be equal to 10 by root 3 kilonewton. I'm sorry, I made a mistake. So this is 270 degree. Okay, so FAB, so this is not minus 30, this is sine 270 degree. Okay, so 270 degree is minus 1, so we have minus 20 by root 3 kilonewton. Okay, so this is sine 30, right, this is correct. If 80 divided by sine 30, so if I send sine 30 to the RHS, I'll have 1 by 2, 2 will be cancelled, I'll have 10 by root 3. Okay, so now I can move on to joint B. So in joint B, I'll have the free body diagram looks something like this. This is FBD, this is FBA, and this is FBC, and this is 10. Okay, so this angle is 60 and this angle is also 60. This is the vertical force, so I can use these formula sigma fx equal to 0. I'll have FBC plus FBD cos 60 minus FAB, so this angle is also 60 degree, right? So I can use FAB cos 60 is equal to 0. So FAB so the next one is F sigma Fy is equal to 0, and sigma Fy we have minus 10 and minus FBD sine 60 and minus FAB sine 60 is equal to 0. So this is minus 10 minus FBD sine 60 minus FAB. FAB is nothing but we have minus 20 by root 3, minus 20 by root 3 into sine 60 is root 3 by 2. And root 3 will be cancelled, this minus will be cancelled, 2 and 10. So we have minus 10 and plus 10 will be also cancelled. So the remaining is, this implies that FBD is equal to 0. So this equation number 1 will be equal to FBC. So FBD is already 0. I'll have minus is equal to FAB cos 60. So I can write FBC is equal to minus minus 10 by root 3 kilonewton. Okay, so 10 by root 3 is nothing but minus 5.77 kilonewton.